Good afternoon, everyone. Thank you, Andre, for giving me an opportunity to present today. My name is Yusuf Mehta. I'm a professor in the Department of Civil and Environmental Engineering and director of CREATES. It's a long acronym right there. And what I'm going to do is give you a snapshot of the growth of CREATES and also tell you some of the very exciting projects that we have been doing. Just a brief overview of Rowan University. Rowan University is one of the two public institutions in the state of New Jersey. So if you drew a line from Philadelphia to Atlantic City, we are 15 minutes from Philadelphia in New Jersey. So the mission is to conduct cutting-edge research, which is applied and readily implementable in transportation engineering. A lot of our sponsors, federal, state, industry, are looking for implementable research within a year or two of finishing the project. And in the process, create a diverse a pool of workforce that can help the industry in the region and in the nation. So CREATE started off as a payments area, as a payment and construction material. We have a certified lab, a nationally certified lab in construction materials, both asphalt and concrete. And as it grew, we absorbed other aspects of transportation. We have got intelligent transportation, safety and mobility, bridge engineering, geotech engineering, and we are now including all aspects of transportation to make it a comprehensive transportation research center. And what happened in 2016 is we got a $3 million heavy vehicle simulator through a CRADA from the Department of Defense, the US Army Corps. And this puts us in a very unique space. We are the only academic institution in the Northeast that has that capability. So along with the certified labs and this facility, we are able to do really implementable research for a broad range of agencies. Next slide. So we have a lot of postdoctoral associates, research associates, and now we have integrated faculty members not only in College of Engineering, even in geography, mathematics, and geology that are all parts of the CREATE Center to make it an interdisciplinary transportation research program. And then we have undergraduate students and graduate students as well to support the mission of CREATE. So we have within 5 years, we have a significant team of almost 20 faculty and staff, plus more than 50 to 60 undergraduate and graduate students. So we are looking at professional development, outreach, workforce development, education, and research, and that is the machine right there. And what it does is the wheel goes back and forth and does 20 years of damage in a few months. And you can see that any agency that wants to implement any form of research that's coming out, they will want to see how it will work in the field. So as soon as we got this equipment, a lot of agencies, even industry stepped in. You know, we have some new product, how can we put it to implementation? And that's what puts us in a very unique space. So a quick research, I wanted to give you a snapshot up front and show our growth. So within the last 5 years, we have really expanded this. We have close to $40 million worth of research. We have around 53% from the federal government, from Department of Defense, which includes US DOT, Federal Aviation Administration, and Federal Highway. That's close to $3 million. Close to $17 million from the Department of Defense, Education, and National Science Foundation. And now we have a broad range of funding agencies, primarily NJDOT, State of New Jersey, and other state agencies as well. We also have a broad buy-in from industry partners. They come in for, and we have a division within CREATE that looks at industry partners and how we can help them take their product to implementation and for the state and county as well. So right here, graduate students. This funding has led to a growth of graduate students. So within 5 years, the doctoral program just started in spring 2016. We have grown to more than 250%. So we have close to 20 PhD. We have more PhD students now than master students that feed into and work on these projects. One of the things that led to this growth, we have something called the GAN program, Graduate Opportunity, our program is called GoStars, Graduate Opportunity in Safe Transportation Resilience Systems, and that's close to a $1.5 million grant that funds 11 doctoral fellows in transportation and 2 in engineering education. So this was a great way to boost our program, and for a relatively new program, that was a big win. And then we have just received Innovations in Graduate Education grant, where we will train the doctoral students to be ready for practice, not only academia. And we have, this is a 3-year program as well. So we have got a huge staff here. This is our presence at the Transportation Research Board. And as I said, we have close to 60 students, undergraduate and graduate students, funded and unfunded as well. Now I'm going to talk a little bit about different subject areas within CREATES. One is the big sponsor is the Innovative Technologies and Materials to protect the national security interests in the Arctic region. That's by Department of Defense, and that's close to $17 million. And then we have innovative solutions for industry partners. We look at bio oils. We are looking at recycled materials. And then we also have a New Jersey Department of Transportation payment support program that's close to a 1.5 to 2 million a year program over 5 years, extended to potentially 10 years as well. So some of the sustainable construction materials, just to give you a little flavor, some of the things we look at 100% recycled asphalt for Department of Defense. When you have an airfield that needs to be repaired, they want to get something fixed right away. They don't want to send the troops somewhere else to get fresh material. So 100% recycled is a big interest to the Department of Defense. And then other sustainable technology like low-emitting asphalt and plastics in cold regions as well. One of the very unique technologies that we're going to talk about, this is the construction technology called cold in-place recycling. So we have emulsions, reclaimed asphalt. This is 100% recycled, mixed cold. And you can see why this is of value in cold regions. You can extend the construction season, right? It can be used for the base material, and you just have to know what is the right recipe that can give you a very good base material and lead to a longer life. So not only a New Jersey Department of Transportation is interested, other agents, other state agencies, as well as the Department of Defense. And develop a right combination of CR based on lab and accelerated payment testing. So when we embark on any of these projects, a lab phase is couple of years, 2 years or so, where we have several combinations, and when we have some promising results, we go into the accelerated payment testing facility, and I'll explain that in a bit. So here you can see on the left, you can see the video that that's what's happening at our accelerated payment testing facility. You have asphalt being removed, can recycle right there when we add emulsions and cement added. Now, this happened after 2 years of research. We went in and we constructed 3 sections. So CREATES has an ability to construct 16 independent sections. And you can do 16 independent experiments. The only thing is we only have one heavy vehicle simulator, right? So that's our bottleneck at this time. So we went into the field, and we got three things: wet mix, high asphalt, balance, and then dry mix. And this, again, happened after several years of lab study. And we traffic it. So you can apply 10,000 passes in a day. So you are really accelerating the damage, and this was done at 50 Fahrenheit. So we have the ability to control the temperature. We can go as low as 0 Celsius and as high as 80 Celsius. So we can do that, and we looked at developing recommendations based on So you can see value here that you can get, this could have happened in 20 years, right? And we are doing that in a few months. That's why agencies like to test it in this after the lab studies are done. Then we looked at something called geosynthetic interlayers. So you put in a grid within the asphalt layer. Grid has been used in soils for years, but this is something new we have tried, is use grid in asphalt. And 2 conditions had to be met. One, it should not melt when the asphalt is very hot. And second, it should be recyclable, right? It should not clog the asphalt. And right here, and we conducted life cycle cost analysis. And right here, you can see the video on the left. you can see the impact of having the grid. Not having the grid, you can see the crack goes right through the beam, and you can see a failure. And on the right, you can see once you have this geogrid, it arrests the cracks, and you see a significant improvement in the life of the payment. Once again, we looked at delamination based on lab performance, and then we went back to the field. So we identified 2 out of 5 from the lab study that went into full-scale heavy waves HVS sections. So right here, we constructed 3 sections and 3 full-scale sections. As I said, we can do up to 16. And you can see those white strips, those are cracks. So we constructed in 2 layers. We failed the layer, put the geogrid, and trafficked it. So we are looking at, in the full scale, how it will perform. These are some of the photographs to show. This is, you can see the snapshot. I wanted to show you, this is how we do several sections, and you can see we install sensors in there, and there is where we have a chance to look at different sensors, wireless sensors, depending on what the problem you're trying to solve, and there you can see installation of sensors. Some of the pictures to show you some of the heavy accelerated payment testing work. It's not going ahead. There you go. And here it is some more. You can see on the left, you can see 2 mats. So out of 5, we came to 2 mats. One on the top left is a basalt, and one is a geotextile. And you can see we constructed this 3 sections. One had geotextile, geogrid, and this. And then we did the heavy vehicles testing, 250,000 passes at 40 kilonewtons, 60 kilometers, and then looked at rutting, cracking, and so on and so forth. So each testing takes a month and a half or 2. So you're looking at this 3 sections can take a 1-year span. You're looking at 4.5 to 6 months. Next, we are looking at electrically heated self-de-icing. This is a very big interest for the Department of Defense and also for DOTs, for bridges, right? Bridges freeze before roadways, correct? So that's a big interest here. And here, Department of Defense is interested because they want the operations to continue in the Arctic region and not have to stop the operations due to snow plowing. So we did, again, three test strips, 1 control, and we developed our own high-performance thin overlay, which consists of graphite and carbon fiber, and there's another one was a patented system. We monitor the heat performance, power consumption, and look at the cost effectiveness. And we are going to apply full-scale truck and aircraft tires. So we have the ability to not only apply aircraft, but also truck tires, also aircraft, which is 250 pounds per square inch. So that's pretty significant stresses on the roadway. So we looked at graphite. You're looking at 30% graphite and 1% by volume of carbon for our mix. Here it is. This is a snapshot of all our sections. You can see that's the hangar photo you saw, and these are all our sections. And that was our piece of the electrically heated test strips. And once again, we constructed, this is how the grid at the bottom shows you the plates that was used for heating up the pavement. And it just needs 24 volts. So it's, and right here, you can see the construction. So it cannot be done for long stretches, or it's very intensive effort. So this is only for short lengths, for bridges, airfields, and you can see we are putting in each of these sections in. Right here, you can see the first, after the first snowstorm, as soon as we install, you can see the little impact of the electric heated system right there. That is when we just installed it. And then 1 year later, next winter, right here, you can see this worked out really well. So you can see the Rowan self-de-icing system just after a storm in January of 2021. And then on the other side, you are seeing a control system. So we clearly see that this system is working. Now, what we are going to do, what is happening now, is we have put the heavy vehicle simulator on this section. We are damaging the pavement, and we are going to look at the efficacy of the de-icing post-trafficking, right? So that's next winter. That's what we are going to check. So very applied, and the Department of Defense, and in fact, DOT is also very, very interested in this project as well. So these are some of the photographs when we had a visit for the Department of Defense and Norcross. couple of other snapshots. We have, as I said, geotech engineering. We do work with wireless in-situ payment sensors, creep and fatigue, and then other soil-related work led by Dr. Cheng Zhu. They are all part of the CREATES team. And then we have several concrete projects within the Department of Defense. We have recycled concrete, cold weather concreting as part of the defense, and Dr. Gilson Lomboy leads that effort. And he has innovative technologies and materials to prevent concrete shrinkage by NJDOT as well, and other projects. Then we are looking at bridge engineering. We have Dr. Adriana Trias as part of the CREATES team working on bridge projects and looking at part of the bridge resource program led by Rutgers University and looking at bridge deck surface profile evaluation. Then I'm going to get into transportation, ITS and traffic safety led by Dr. Mohammed Jalayar. Traffic safety, traffic operations and evaluations, driver behavior, ITS, and big data analytics. I'm just going to touch on a few projects. So right here, the first one, we just received this grant. This is Smart and Connected Atlantic City Expressway. This is funded by the US Department of Transportation. Dr. Jalai is co-leading this effort with me. And basically, it's a multi-university. We have Rowan, Kennesaw State, Clemson, University of Alabama, West Virginia, and Leidos is going to be putting in sensors along the Atlantic City Expressway. So basically, to transform the existing Atlantic Express into a smart and connected corridor, they are putting in gantry for cashless tolling, and we are going to use that as a test bed to evaluate cellular vehicle-to-everything technology, tolling, and an infrastructure in-loop simulation to accelerate V2X. So this will be one of the unique features that will come out of this project from the Atlantic City Expressway cashless tolling. And then the benefits is right here. There'll be a near real-time evaluation of algorithms, optimizing of the resources. And then for the users, there'll be cashless towing, support for conventional vehicle and future riders, will reduce congestion. And we are also going to be looking at discounted rate for pre-scheduled rides. So some of the other benefits that will come out of this project. Some of the other projects that Dr. Jalayar is leading is a real-time proactive intersection safety monitoring system based on video data. And he's using innovative AI-based video analytics, look at intersection safety, non-compliance, jaywalking, and also looking at historical data. This is funded through the University Transportation Center led by Rutgers University. And these are some of the data collection methods that he has employed, looking at pedestrian jaywalking, running a light, and so on and so forth. Then another one is a novel approach to identify distracted driving. This is to develop an AI framework to detect and classify distracted driving using video data, and also looking at the effect of temporal variables and geometric design features. This is funded by the Highway Traffic Safety Division. And he's looking at taking pictures, taking videos, and analyzing data based on that. And some of the key finding, which has got a lot of publicity, that 1 in 5 motorists are driving distracted in New Jersey, and a lot of distraction more on the weekdays than on weekends. So this has led to a lot of publicity, and a lot of policy changes will come from this study as well. The next one is the mobile data collection platform for transportation asset management. This is a key for municipalities. Municipalities do not have a large budget. This is a very low-cost system where you can put in a low-cost camera on the bumper and collect data. And we are doing this for a borough of Collingswood. We are trying to provide an asset management, payment management system for them. And what it allows them to do is rank their roads when they have funding available to resurface some of this. So this is some of the overview. This is how we are doing using the vehicle. And so we collect payment distress data, we analyze the data, and we are going to develop a new payment condition index for boroughs. So this is a very good way to replicate in other counties as well. So you can see the breadth of the work from Department of Defense to the county we have covered. Then one of the things which is the first and last mile, we are looking at improving health and access to transportation for Camden's vulnerable populations. And as the first and last mile is one of the shortest in terms of distance, but that could be the longest in terms of travel time, right? So going to the bus stop or going from the bus stop to the school or to the hospital or what it may be. And Camden, this study was done in Camden where 58% of the households do not have vehicles. So we are looking at recommendations like better safety patrolling, shuttles, lighting, so residents can go to the nearest transportation, either it's a bus or a train, safely, and also get service at the other end. So that was a research update, a quick education update. We are hosting the National Summer Transportation Institute, and we have been doing that for several years, and we are hoping to do this next year as well. And what we do is we get 20 to 30 students from all over New Jersey and give them a flavor of transportation, all modes of transportation. And we take them to all these different sites, Atlantic City, Port Authority of New York, New Jersey, Septum, and the bridges along the Delaware River as well. So these are some of the projects, and other projects are listed right there. And these are some of our trips to different places, and they really get a front seat view of some of the activities. They get a chance to see Atlantic City at the back end, to look at how the security system works, air traffic control works. It's a phenomenal experience for the students. We have also started a couple of other programs. The Creates Fellowship program that is funded purely by industry partners. And what we do is they invest in the students, and all they do is they do a presentation to the industry partners. They interview them and possibly hire them for internships or jobs. And then we have just started a national internship program called the Create Summer Research Internship Summer Program. Last fall, we started pretty late, so we had one student. We are hoping to get more students next fall. And these are some of our collaborators, and thank you.